Welcome to the Climate Change and Business Adaptation course. In this course, we're going to be talking about a lot of different facets that all contribute to climate change and the ways that businesses integrate into this, whether they're contributors or they're people who create really cool technologies that help to actually decrease carbon dioxide. Really, I want you guys to think about a lot of things in context with the Paris Climate Agreement and the most recent IPCC report, which came out in 2018. All of these you can easily look up on the web, and these are things that you should really make sure that you know. We will be discussing them and reviewing them as we go, but for part of your portfolio, you need to understand exactly where we're at with regards to responses. Population growth is probably one of the main drivers right now of a lot of the challenges that we have. As you can see from this graph below, it took a long time for our population to grow, and really it's been this exponential growth in the last little while that has really taken everybody by storm. It took basically 150 years for us to reach 3 billion people, if we look at the dip in population that we had during the plague. And then since then, our numbers have just grown exponentially. We're going to talk a little bit about this as we go, but realistically, for somebody like my mom, the population of the world has doubled during her lifespan. It's pretty crazy when you think about it. You think about the limited space we have, the limited resources, and how the demand for resources continues to increase as people increase their standard of living and move to more of a Western type of a civilization. One of the big questions that are facing a lot of folks today is, what's the world population going to stabilize at? I can tell you 10 years ago when we were talking about this, we said, population is going to stabilize at 8 billion. It's not going to go over that. We're going to be okay. And today, we're approaching 8 billion. So things keep happening. Our population has not yet been super limited, but we're starting to see more and more issues of climate change leading to refugees because of the interpolitical issues that happen when you start to have limits on resources based on the number of people that you've got in any particular area. To give you an idea, I was born in 1980, and when I was born, the population was 4.5 billion. My mom was born in the 1950s, as I mentioned, and the population was only 2.6 billion then. It's really this exponential growth in the last little while that has caused this huge drain on resources. And so we have to find a way to have a carrying capacity that hopefully doesn't involve mass starvation and death. We are going to have to look at people breeding less and having less children so that we can have a more stable population without all the negative consequences that come with trying to stabilize that population. But what's interesting is that Malthus theorized a long time ago that there were basically two principles of human population growth. One was that human populations can grow faster than the increase in food production, and two, that unless people are starving, they'll continue to reproduce. So these start to invoke some really big questions. Who do we feed? What's a better type of population control? How can we enact that? And how can we make sure that we do enact these types of population controls so that we don't end up with children and other people dying of starvation and having just really poor quality of life? So what we have here is what we call a Malthusian dilemma. The world's population continues to grow, and by 2050 it's projected that the world will host approximately 10 billion people. And that's only if population growth slows much beyond what is happening now in the developed world. Today, already, we have at least 1 billion people who are chronically malnourished or starving, and simply to maintain that sad state of affairs would require the clearing of 900 million additional hectares of land. We don't have 900 million additional hectares of land that we can clear to farm, except maybe in really the climates we don't want to do it in, places like the Amazon or in Indonesia and things like that. But the problem is, if we cleared those lands, we would lose the massive carbon sink and the resources that those basins give us to help us survive, as well as the fact that those soils tend to deplete very quickly in a short period of time. And so you may get a little bit of a boost in food production, but it's not going to sustain us in the long term. So with that Malthusian dilemma, we really need to think about how do we feed a population that's expected to reach 9 or 10 billion, depending on which study you look at, by 2050. And how do we also grapple with poverty as well as climate change, dead zones, biodiversity loss, and all the other environmental ills that we're going to be facing? It's going to be a challenge, and it's going to be up to you guys to drive these types of new technologies and innovation so that we don't have to end up with a really sad state of affairs. When we look at some of the worst offenders from an ecological footprint, Canada's right up at the top of the list as well. So if we look at our ecological footprint, Canadians are the second highest in the world, just after the US. And if you look at total energy consumption, you see that the US, EU, and China are right up there at the top of the list for total energy consumption, and the tons of oil equivalent per person, if you include Canada, puts us right up near the top of the list as well. So we really do need to think about how to do things differently and how we can do things better. So as we think about population, the agricultural revolution, the availability of antibiotics, vaccines, and pesticides have all contributed to our overall increase in life expectancy. And our life expectancy is estimated to have been more than doubled over the course of the 20th century, from approximately 30 years to nearly 65. It's expected that the population will continue to grow over the next 2 decades because a large percentage of the population is in the most populated countries are of or will reach childbearing age during this period. And this is a phenomenon known as population momentum. According to most recent estimates, the population will continue to increase by 1.3% per year, adding about 78 million people each year until we reach 9 billion by 2040 or maybe 10 billion by 2050. There's a lot of different estimates out there depending on which models we use. I'm really hoping that we can find a way to reasonably limit world population so we don't go much above 8 billion, but I know that that's unrealistic. Some of the things when we think about population growth, we talk about or think about wars and how those have limited population over time. World War II, for example, was just awful. There were 40 million people killed in a span of 6 years. Devastating. If you talk to any of your grandparents or people that lived during that time, they'll tell you about how devastating it was that every day they would hear that somebody else was killed. At that point, the global population was 2 billion. So really, what we were looking at there was just a drop in the bucket when we look at 40 million people dying. When we look at growth that we've had since then, at about 2% per year, which, when you round it down is like hundreds of thousands of people a day. Really, the war and those 40 million people that died had no significant effect on population growth overall. So where I'm going with this is the sad state of affairs that we're in is that even if tons and tons of people die due to war and starvation and all these other things, we're still going to have a population problem. So let's find a better way to deal with this. We have only finite space, and we only have a certain amount of space where we can fit everybody. The carrying capacity of Earth, a lot of people have projected as different things. We can think about solar energy. So solar energy is about 10,000 times global energy use. Global energy use equals sunlight on 20,000 square miles. Globally, about a third of arable land is used for crops. And if the U.S. population, which is about 5% of the world population, uses 25% of the resources, it would take approximately 5 times Earth's current resource output just to raise everyone to our level. So really, when we're thinking about the carrying capacity of Earth, I personally think we're already beyond it. I think the carrying capacity of Earth is pretty close to 7 billion. And we need to figure out how we're going to deal with this, because it's going to be a significant challenge. Large populations also typically adversely affect the environment. Leads to decreasing biodiversity, changing landscapes, pollution increases, both from the wastewater perspective, but also from a waste and landfill perspective. One of the things you've probably heard about a lot in the news is all the plastic pollution and how people are now trying to decrease and limit plastic pollution, as well as nutrient pollution. So one of the things we're going to talk about in this course is eutrophication and how exogenous nutrient applications to farmland has led to marine systems that end up with way too many nutrients, leads to algal growth, and eventually leads to what we call eutrophication, which is where the algae die, consume oxygen as they break down, and it leads to dead zones and fish deaths and no oxygen in the water column and all that kind of stuff. So these are all different types of issues that we're going to discuss throughout this course and that are really important to the study. If we go back and think about some other populations which have basically depleted their environment and led to their overall demise, we can look at the Mayan people as a case study. So they had basically overpopulation, overextended their resources, and they had depleted their soil. They were a pretty advanced civilization, and they wiped themselves out in a very short period of time. And some of the reasons are there was a major drought that hit the region for quite a while, leading to decreases in food. The decreases in food, you had people starving, and then they began fighting for the few resources that were still available. This fighting then led to folks killing one another. We had further environmental degradation, and all of these pieces put together led to a demise of a society that was fairly advanced and that had done great things in the area they lived. And they lived in an area where it was easy to grow food and to replenish their soils through flood or irrigation and other types of events. And they had a lot of really good things going for them. But they still ended up undergoing this major demise and basically civilization apocalypse. We don't want to see that happen. We have already seen what happens when we have slight changes in things. So in the 1930s, there was the Dust Bowl, which you may or may not have heard of. It was a 6-year drought that hit the United States, and a lot of this had to do with wanton farming practices, a lot of land clearing, no buffer zones, all these types of things. And when you had a drought, everything basically turned to dust. And then you had dust just blowing and blowing and continuing to degrade farmlands, cause a lot of issues. And we ended up with major issues when it came to food supply during this time. So if we think about these examples and we try to learn from them, one of the things we can learn is that complex societies are still sensitive to climate change. And when we look at paleoclimate records and we look at variability in the paleoclimate did not have huge variations, and there were still local climatic changes of events due to human activity. We're now talking about global climate change due to human activity or anthropogenic sources. And we're going to have to figure out how to deal with this, or we are going to have major collapses within our food system, within water availability, and within our ability to manage our population. So again, if we take from these lessons of the past, the idea that climate and how climate affects weather really matter, I want you guys to start brainstorming and thinking about ways in which your activities can actually help us to be on a path that's going to be productive for Earth. Again, when we think about lessons from the past, we can look at these environmental problems seriously, and we can start to understand that globalization affects everything. And right now we're starting to see the crises in Syria and Afghanistan and Iraq, and all of these are shaping the population of Canada today. These are shaping our workforce, but these are also shaping regions that used to be fairly productive and be able to sustain their people, and turning them into regions that are basically desert. So when we really look at how climate change affects environmental resources, there's a whole bunch of different things to consider. With climate change, we see things like increased temperatures, which lead to sea level rise, extreme weather events, allows insects and other organisms to move into areas that they didn't before. So we get infestations. In Canada, for example, we have ticks, the emerald ash borer, a fair number of different disease agents that have moved through. We also see, due to sea level rise and extreme events, coastal flooding and damage. All of this can have major impacts on food and water and housing and shelter for folks. We also couple our climate change with our thirst for more agricultural land. Then if we look at deforestation, with deforestation we have increased rates of runoff because we no longer have the tree and the soil and the roots in the soil to stabilize the environment. We also end up with changed hydrological cycles as transpiration rates from plants change, meaning that you have less evapotranspiration. This then leads to changes in weather, it leads to changes in precipitation, and has big effects on the environment. We also end up with more erosion and silting running into waterways. That erosion and silting that runs into waterways ends up degrading the quality of waterways as well. And all of these things open us up to more frequent droughts, floods, extreme types of events. And then we add into that the degradation of farmland. So we see erosion of soils, we see nutrient depletion of the farms, we see more compacting or even salinization, which is where soils become salty due to evaporation. And we even see soil loss due to urbanization. So I live in the Ottawa area, and one of the things we see here a lot is that old farms are being bought up and just turned into houses. And so all that beautiful topsoil that used to be there to farm is now gone, and the farmland is gone. So we're losing some of these potential resources that we drastically need. All of these things, when we look at it from a climate change perspective, results in reduced water availability for humans, as well as reduced food availability. When we think of water availability, right now there's 2.3 billion people that live in water-stressed areas, and 1.7 billion live in what we call water-scarce areas. So water-scarce areas are those where it's really only through extensive tunnel systems or deep wells that they're actually able to access water. Although there are some very cool water harvesting technologies that are being developed as well. But by 2025, it's projected that 3.5 billion people will live in water-stressed areas, and 2.4 billion will live in water-scarce areas. And by 2100, 1/3 of the world will be at risk of extreme drought. So obviously water and understanding who allocates water usage and who has the ability to regulate who has access to which water is going to be a big thing. So one of the areas that Canada has always looked at is in NAFTA, water has always been listed as a non-commodity, so it's not allowed to be traded. But there's an interesting dynamic there as well, because we see that although water is not supposed to be traded, people can bottle water and sell it for commercial purposes. So sort of where does that crux and dilemma lie is another interesting piece of the puzzle. So also as we look at food supply and climate change, we know that grain yields decrease by 10% for every 1 degree Celsius increase in global temperature. And we know that a 2 to 3 degree increase is likely, but a 3 to 5 degree increase is actually possible now that we haven't been able to significantly draw down carbon in the atmosphere. So what this means is that we are likely to have a 20 to 30% or even up to a 50% decrease in grain yields, which will have a massive effect on our ability to feed the world. If we look at a quick case study here of Syria, to give you an idea, we've heard a lot about Syrian refugees, and to understand sort of what led to the current issues within Syria and all of the refugees, a lot of it comes back to climate change. So basically there were 22 million people living in an area the size of North Dakota, so not unreasonable population numbers. It was a hot place, it was hot and dry summers, rainy and mild winter, and it's basically a middle-income developing country. It was about 11% below the poverty line, and 10% of the population in 2007 were listed as refugees. So they were people coming from Iraq, Palestine, and Lebanon to Syria. And what ended up happening there is we had a local climate change event, which we'll talk about on the next slide. But we also had a repressive government and some corruption ongoing. And climate change was the piece that just catalyzed the whole situation and led to major challenges. So if we look at the Syria Vegetation Index, what you can see is that in this index here, a very good season is the gray color, and a really bad season is red. And so if we start out in 2000, what you can see is that there was some drought in the region, some challenges. And then as you follow this along, it looked like things were sort of getting better as we had seasonal shifts. There were good times for producing food, but then they were hit by a fairly severe drought, and that affected about 60% of the land area. And there was basically 75% of the crops were lost. So during this time, herders had to sell their animals because they couldn't feed them, and they sold them for significantly below the prices that they would usually have gotten for their herding animals because everybody went to market to sell at the same time. They all of a sudden didn't have food to feed all of their people, so now they were, for the first time, having to import wheat. You had sandstorms happening twice a week, and basically it led to the abandonment of the family farm. And so here's an example of what used to be a farmland, which is now just sand. So drought, in this case, drove the significant portion of crop loss, which then led to the selling of the animals, the loss of the farm, and all these negative interactive effects. Then what ended up happening is a lot of the people, so about 1.5 million who lived on farms, migrated to the city because they had no options in the country. When they moved to the city, there was a lot of poverty, there was some social unrest, and this led to even further challenges. The severe drought that Syria faced from 2017 to 2010 caused 1.5 million people to migrate from the countryside into the cities. And when they did that, they didn't have jobs, so there was more poverty in the area. There weren't any government programs to support them, so it led to more social unrest, and this eventually led to the Arab Spring that Syria had. And the Arab Spring from Syria was fueled by the Arab Spring from Egypt and things like that, but also was in response to negative government responses. There was actually a peaceful protest taking place as part of the Arab Spring in Syria, and the government actually rounded up the protesters, tortured many of them, killed many of them, and this led to the formation of an anti-government army who was then dead set against the army. And as soon as this happened, all of the other players started to get involved. So you had this internal war, which then all of a sudden surrounding countries got involved in, and the Americans got involved, and Russia got involved, and there's all these things then happening. And so it's really easy for something that happened because of an extreme event as a function of climate change then led to the decimation of an entire area and millions of refugees looking for new homes. So really we can see that these small things that can happen driven by climate change can have large, wide-sweeping, drastic effects. I put together a little schematic here just to give you an idea about how climate change could affect the global food system and all the feedbacks. And with all of these systems, what we see is that there's feedbacks in every direction. So climate change can lead to changes in global food production, which can then lead to further changes in climate change depending on how that food is produced. They can all have interactions and effects on global food supply. And all of these can have social, political, and economic factors which are driving distribution, availability, and all those things. But also all these social and political factors can have huge effects on what ends up happening in the spaces that are being impacted. So we can have poverty, we can have major conflicts, we can see crazy things happen with food prices, as we've seen happen in Russia before. There's a lot of pieces that get tied into this whole puzzle. So in general, when we think about the whole climate change picture, I really want you to think about all of the different components that we're going to discuss in this course and think about how they play into the grander puzzle. When we look at an emerging area, I think Pakistan is ground zero for global warming consequences. There was actually a really interesting article in USA Today about how Pakistan could be the next area that undergoes significant changes similar to what Syria has seen, and this may be the next area that we see major numbers of refugees coming from. The challenge here is that the population of Pakistan is much, much greater than the population of Syria. So if we start seeing this huge wave of refugees, I don't know where they're all going to go. But with Pakistan, basically it produces 1% of the greenhouse gases in the world that affect global climate. So not very much at all. But they are drastically affected by global temperature increases. So their temperature increase has been somewhere around 4 degrees Celsius per year, which is a lot higher than a lot of other areas. And in April of this year, one of the cities had, and this is April, right? So this is not the middle of the summer, not the middle of the winter. It's during what's supposed to be a temperate climate time their temperature reached 50.2 degrees Celsius, and this was the hottest day on Earth ever recorded in April. There were a lot of deaths related to heat, and to combat this problem further, they have depleting water supplies, and 60% of the land receives less than 10 inches of rain per year. So most of the rivers are mainly fed by the Hindu Kush Karakoram Himalayan glaciers, and the glaciers are melting at a rapid pace due to global warming, and eventually those glaciers will no longer exist, which means that then there won't be enough water coming into this area. We're going to see massive drought, the inability to be able to produce food for all of these people, and again, leading to major challenges. They've also been clearing a lot of forests in Pakistan for urban development, and this reduces the environmental buffering effects that typically farmlands have on both climate, but also on actual farmlands and fertility of farmlands as well. And their population is projected to add nearly 100 million people by 2050, which is going to cause even greater strains on their resources. So they have all of these ambitious plans for economic development and things like this, but in doing so, they're going to increase their carbon emissions by over 300% in the next 15 years. They're going to end up with more cars on roads, clogging the city, leading to decreased air quality, all the while having less and less resources. So I think this is an area that's emerging, and it's an area that is going to need ideas to solve the major challenges that they are going to face. So it's interesting in some ways. I feel like this political cartoon sort of sums up some of the challenges that we're facing. It says, now for religious and political reasons, let's pretend none of these are related to overpopulation. So energy crisis, food crisis, water crisis, environmental crisis. Everything comes back to population. The Ehrlichs have been talking about world population being a challenge for a long, long time, so you'll see lots of quotes from them. Here's another one. The penalty for our frantic attempts to feed burgeoning populations may be a lowering of the carrying capacity of the planet beyond its present level. And really one of the things that they talk about a lot is that everything we do to actually prevent people from starving actually allows those populations to thrive in areas where those populations really aren't sustainably able to survive. So there's a lot of different conflicts here. There's a lot of pieces that you guys are going to need to tease out and bring together as we go through this course. So a lot of different cities and areas are developing what they call action plans. Here's an example of the city of Calgary's action plan. They're talking about both mitigation and adaptation as a way to minimize their climate impacts. So realistically, they have an action to reduce emissions. So this is more sustainable transportation, electric vehicles, moving away from big gas guzzlers and things like that, clean energy development, and then making sure that everything is done in a more energy efficient manner. And then they're also having adaptations for potential climate change impacts so that doesn't cause a positive feedback on the challenges that their system is facing. So every different city has a different type of action plan, and in Canada, our cities are actually going over to Europe a lot. There was a big commission that went from Ottawa recently over to Europe to see what the cities are doing there as well, so that they can try and minimize their climate change risks. So with that, I'm going to leave you with this final slide. When we look at the stages and development of an environmentalist, we all sort of start in this sort of innocence, ignorance is bliss kind of area, and then we move along this scale, and that knowledge leads to feelings of guilt. Guilt typically leads to changes in lifestyle, and then people typically become activists and evangelists for trying to live more sustainably. And when we all do this, we all reap internal rewards. And that's where I'm trying to get you guys to. I want you to be able to be an evangelist for sustainability in business, in life, and in everything that we do. So, welcome to week 1. Happy to work with you guys.